Okay, so I'm going to talk about the elimination method for solving systems of equations. Right now, if we encounter a question like this where we're given two equations and we're told to solve for x and y, the only way we know how to do this is through substitution. So I'm going to walk through this problem using substitution just as a quick little reminder. So I'm going to pick one of the equations and solve for either x or y. In this case, I'll pick the first one and I'll solve for x. So I have x plus 2y equals 8, and I need to get that x alone. So I'll subtract 2y over here and subtract it over here, end up with x equals 8 minus 2y. Okay, now that I know what the whole x value is, I can take that and plug it in for my x here. So it would be 5 times that whole x value, 8 minus 2y, minus 2y equals 4. And then I would be able to solve for y from this equation. But I'm not going to walk through the whole thing. Now I'm going to show you another way to do this called the elimination method. And this is probably one of my favorite ways to do it. I don't know why. This was always my favorite method. But you kind of get to pick which method you like the best, which one works the best for you. You do need to know all of them somewhat, but you get to pick which one you like the best. So for the elimination method, let me just break down these equations and show you kind of what they actually mean. So let's say you had something that says x equals 8 and y equals 4. That's like a simplified version of what we have here. You have a value equals 8 and a value equals 4. So you could also say that the value of x plus y is the value of 8 plus 4, right? If you add x plus y, you'll get 8 plus 4 because x is 8 and y is 4. So this is why the elimination method works. I'm going to take the two things on the left side of my equal sign and add them together. And then I'll take the two things on the right side and add them together and set them all equal to each other. So I'm just going to turn this into one big addition problem. So first I'll add my two x values, which is just the x plus 5x here. And when I add x plus 5x, I get 6x. Then I'm going to add my y values here. I have 2y minus 2y because I'm adding a negative 2y, which leaves me with no y's. So I don't even have to write anything. That would be 0y or just 0. And then I add my last terms, the 8 and the 4, and I get 12. So I can say that 6x equals 12. And now that I have one variable alone, I'm able to solve for that one variable. Because basically my whole goal is being able to solve for either x or y so that I can plug it into the equation and be able to figure out the other variable. So now I have it set up so that I can figure out what x equals just by dividing by 6 over here and dividing by 6 over here. So I learned that x equals 2. And now that I know x, I can take it and plug it into either one of these equations to figure out what y is. So I'll pick the first one. I know that x is 2, and it's x plus 2y equals 8. And now I can solve for y. So I'll get rid of the 2 here, get rid of the 2 here. I have 2y equals 8 minus 2, which is just 6. Divide by 2 over here, divide by 2 over here, and I know that y equals 3. So I have my x equals 2 and y equals 3, which is just an ordered pair, 2, 3. And I was able to solve for that answer. Now let's look at a more complicated one. So I have two equations here, and in order to solve for either x or y, I'm just going to add them up. So I'm going to line up all my x's and all my y's. Let me rewrite this out as a whole addition problem. So I rewrote them and I lined up all my variables because remember I can only add like terms. So I put together my x's and I put together my y's and I put together my constant terms. It did actually already have them all lined up in this equation over here. I just kind of wrote it to be a little bit more organized. I'm going to take these and add it all together. So 2x plus 3x is 5x. I have a negative y plus 4y, which is -1 plus 4, which is a positive 3y, equals 13 plus 3, 16. So we have a little bit of a problem here. This equation that I just solved for does not help me solve for x or y, because it still has an x and a y. I need to make this equation something that only has an x or only has a y. Otherwise, it doesn't really help me. So there's another way that I can manipulate this problem to get it to do what I want. So instead, I'm going to go back to before I even added anything up. Just get rid of that. And I'm just going to look at my equation here. There's no variables that will cancel out. I need something to cancel out. Last time I had a -2y and a positive 2y, and those canceled out. This time, I don't have anything like that. So I need to make this equation have something like that. And to do that, I can multiply a number by the whole equation. Because I can multiply any equation by any number and it still stays equal as long as I multiply it by that on both sides. For example, if I had 4x equals 1, that's the same as if I multiplied everything by 2 and made it 8x equals 2. Those are equivalent equations. So I'm going to do the same thing with this thing over here. And I'm going to multiply it by things that will help me cancel something out. So I see a clear setup for that here. I have a -y and a positive y. That's getting me really close to canceling out of y's, but I'm missing a 4. I need it to have a 4 there so that it subtracts 4y and adds 4y and gets rid of my y's completely. So to do that, I'm going to multiply the whole first equation by 4 on both sides to make it still be an equivalent equation. So if I multiply the whole thing by 4, that 2x becomes 8x. -y becomes -4y. And the 13, when multiplied by 4, becomes 52. So I multiplied it all by 4. And now I can add it up and actually be able to get rid of those y's. So let's go through this again. 8x plus 3x makes 11x. -4y plus 4y cancels out of all my 4y's. And I can say that that's equal to 52 plus 3, which is 55. Now I have something I can actually solve for. I have 11x equals 55, and I'm able to figure out what x equals. I divide by 11 over here, divide by 11 over here, and I get x equals 5. And now that I know my 5, I can take that and plug it back into the equation. And it doesn't matter which equation I choose, because whether I plug it into the first equation or the second equation, I'll still get the same answer for y, because the x is the same in both equations. So I'm going to do the second one this time. 3 times my value of x, which is 5, plus 4y equals 3. 3 times 5 is 15, plus 4y equals 3. Now I have to get rid of that 15 over here and get rid of it on the other side. I get 4y equals 3 minus 15, which is -12. And I divide by that 4. And I end up with y equals -3. So now that I have an x and a y, I have the coordinate, which is 5, -3. And that is my final answer. Okay, let's try this one. So right off the bat, looking at these, there's not really any variables that look like they'll be that easy to eliminate. There aren't any that will eliminate themselves, and there aren't any variables without a constant. So I don't have something that's just going to be 1 multiplied by something like in the last example. I'm going to have to multiply both equations by something so that I can get rid of a variable. And I get to choose which one I want to get rid of. So let's try to get rid of the x. I have a 2x on the top and a 3x on the bottom. And I need to make those cancel out. So the easiest way for me to do that is to pick a common multiple and make them both be that common multiple. So what I'm going to do is multiply the top equation by -3 on both sides, and the bottom equation by 2. And let me show you why that works. So if I multiply the -3 into every single term, I end up with -6x plus 9y equals -15 on the top, and my bottom equation multiplied by the 2 in every term becomes 6x plus 8y equals -36. So because of what I multiplied it by, now I have something that's going to cancel. I have a -6x and a positive 6x, which leaves me with 0x when I add them together, or no x's. It allows me to get rid of the x's. So let me add these equations together. I got rid of my x's. 9y plus 8y gives me 17y equals -15 plus -36, which is -51. And now I'm able to solve for y. And I get y equals -3. And now that I have one of my variables, I can solve for the other one. So I'm going to choose to plug it into the first equation. That was 2x minus 3 times my value of y, which is -3, equals 5. And now I just have to solve for x. So I have 2x plus 9 equals 5. Get rid of the 9. 2x equals -4. And x equals -2 once I divide through that 2. So my ordered pair is -2, -3. And that is my answer. So here are your steps as a reminder. Number 1, line up the equations. Make sure that all of your x's are in a line, all of your y's are in a line, and all your constants are in a line. Number 2, choose a variable to eliminate. Pick that you want to get rid of the x's or that you want to get rid of the y's. And in order to do that, multiply an amount that will make sure you can get rid of either those x's or those y's. Make there be a negative number and a positive number so that it cancels out. And the last step is just to add both equations together and solve for your other variable. So let's say you eliminated the x's, now you can solve for your y. And once you know your y, you're able to actually solve for the x.